the test statistic we've been using has been a difference in means. Maybe the mean number of months lived under old drug minus the mean number of months lived under new drug. But you can't take the mean of 0 and something bigger than 12, right? We don't know how to do that. So what we do instead is we try to think of a way to transform our data, such that we can represent this number in some useful way. And the way we're going to do that is we're going to convert each of these numbers into its rank within the data set. We're going to convert it into its rank within the data set. What do we mean by that? Well, let's look at our 4 numbers, 3, 7, 0, and 12. And now it's 3, 7, 0, and greater than 12. And just to give myself more space, let me write these right above. This is greater than 12. Okay. This is the original. And now we're going to convert these into ranks. The lowest number of these 4 numbers, grouping all 4 of these together, the lowest number is 0, right? So its rank within the data set is 1. In other words, it's the lowest. Okay, what's the second lowest? Well, that's this 3 over here. The third lowest is this 7. And the fourth lowest, in other words, the highest, is this one. We converted the data into ranks. Why would we do that? Clearly, we're losing information here. Clearly, the numbers 1, 2, 3, and 4 do not reflect how far apart from each other the numbers 0, 3, 7, and at least 12 are. However, note that I'm sure of these ranks, and these are numbers that I can add together, that I can take averages of. I'm sure that this person who lived at least 12 months lived more months than anybody else in this data set. I'm sure that if I convert each of these values into its rank within the data set, this is the person who lived the longest. So even though I'm losing information when I convert to ranks, at least now I have some values that I could actually do some math with. Whereas here, I'm stuck because this is a censored value. Meaning that after 12 months, I stopped collecting data. Anything that was not fully implemented or fully realized by that point is censored. It's at least 12. Okay. So now, using these ranks, we're going to just do a randomization test. So let me write down the 6 different ways that we can allocate 2 of these people. This is person 1, 2, 3, and 4. 2 of these people to group A and 2 to group B. So let's do that. Let's see. Could look like this. Okay, and there's 6, so I think I got all of those. Here are the different ways that when I put 4 names in a hat and draw 2, 2 of these people could end up assigned to group A and 2 could end up assigned to group B. Now what we're going to do is we're going to assume the null hypothesis is true. This is going to be the same null hypothesis we used for the randomization and permutation test, except now it's on the ranks. So we're going to assume that your ranked outcome within the data set has nothing to do with which group you're in. With the randomization and permutation test more generally, we've been saying that the null hypothesis is that your outcome would be the same regardless of which group you're in. This is the same null hypothesis, but now we're talking about ranks. We're thinking of this as the data set. Your rank would not change if we had assigned you to the other group. So under that null hypothesis, regardless of whether person 1 is assigned to group A or group B, the rank would always be 2. Regardless of whether person 2 is assigned to group A or group B, the rank would always be 3. And so for each of these different possible random allocations, for each of these possible randomizations, I should be able to calculate any summary I want of these numbers. In particular, the rank sum test statistic, it's often called T, is the sum of the ranks in the smaller group, just by convention. We could also use the bigger group, but by convention, it's the smaller group. And of course, here the group size is the same, 2 and 2, so it doesn't matter which one I use. So how am I going to do that? I'll make a column of the values of T here. For each of these possible random allocations, I'm going to add together the two ranks associated with the people who would have been assigned to group A. So for example, these two people are assigned to group A, 2 plus 3 is 5. If these two people are assigned to group A, 2 plus 1 is 3. Here it would be 2 and 4 is 6. Here it would be 1 and 4 is 5. Here it would be 3 and 4 is 7. And here it would be 3 and 1 is 4. You see what I did? For each possible random allocation, I'm going to add together the ranks of the two people who are in group A.